Hello everyone, this is Balaji Tripathi. Now in this video lecture I am going to tell you how to calculate the radiation intensity of antenna. So this is lecture number 2. So we are going to calculate the radiation intensity of an antenna. So basically we define the radiation intensity of antenna is amount of power radiated by antenna per unit solid angle is known as radiation intensity. So amount of power radiated by an antenna per unit solid angle is known as radiation intensity of an antenna. The unit of radiation intensity is watt per steradian. The unit of radiation intensity is defined as watt per steradian. So before this we know how to calculate the power density of an antenna. So based on power density also we can calculate based on power density we can calculate radiation intensity. Let's suppose we have an antenna here and it is radiating like this, and here we have power density is there, that we mark by W, and the distance between this is R. So if I have this data, I know that radiation intensity can be defined as U is equal to W into R square. Power density, W is power density into R square, and the unit of power density is W by meter square. So meter square will get cancelled, and we will be left with the W by steradians. So we know that power density is equal to based on the electric field E square by 2 eta. Based on the electric field that we have seen in the previous video, based on the electric field, power density is defined as E square by 2 eta. So radiation intensity will be equal to R square into E square by 2 eta. After substituting the value into the E square by 2 eta, so based on this radiation intensity, we can calculate P radian equal to power density, a solid integration of radiation intensity, that is solid integration of radiation intensity, and based on this we can calculate the radiation intensity also. Based on power density also we can calculate, and that will be equal to W dot, that based on power density we can calculate, that is surface integration of density, and when we will open it we'll get d theta d phi. So based on the power density, we can, based on the radiation intensity, we can calculate power radiated, P radiated, that is solid integration of radiation intensity, and based on the power density also we can calculate power radiated, that is W into ds, that is surface integration of density. When we'll put the value here, we'll get theta u theta sin theta d phi. Thank you. Now in the next video I will show you the example how to calculate on the basis of radiation intensity and radiated power.